Hello smart people, and welcome to another statistics video. In this short video I want to discuss with you the empirical rule. The empirical rule is introduced in chapter 2, and you will learn much more about the empirical rule in chapter 5. Now the first thing I want you to understand about the empirical rule is it applies only to a special type of bell-shaped data distribution. So if you have a data distribution that's skewed to the left or skewed to the right, or is any shape other than a bell shape, the empirical rule does not work for those types of data distributions. Now this special bell-shaped graph is perfectly symmetric. And because it is symmetric, the mean of the data lies at the center of the graph. Now shown below is a histogram that displays a bell-shaped distribution. And you see I have outlined the histogram with the bell shape. Now one of the things you can conclude pretty quickly from this bell-shaped symmetric graph is that if you add this line of symmetry that divides the bell shape right down the middle, then this red dot here represents on the scale the mean of this data set. And so if this is a dividing line of a symmetric distribution, then that means half of the data is over here, 50%, and the other half of the data, 50%, is to the left of this red line. Now, there are some other percentages that we can talk about of data within this distribution. So here you see I've taken my x-axis and I've located mu right in the center of the distribution, and I have graduated this scale in units of sigma. So here we have a distribution. It has some type of standard deviation. I don't know what the standard deviation is, its exact value, but we'll just call it sigma. But I want to be sure that each space on this scale is equal to sigma. Now, having drawn a scale graduated by sigma, if I take my pen and I draw a vertical line right here and another vertical line right here, see I've gone 1 sigma to the right of mu and 1 sigma to the left of mu. And then if I shade that area in here between those vertical lines, shade all this area here, what the empirical rule tells me is that in this shaded area, that's where I would find 68% of the data. So 68% of your data falls between this point, which is mu plus sigma, and this point, which is mu minus sigma. Now let's look at another sketch. This time I'm going to go 2 standard deviations to the right and left of mu. So I'm going to go 1, 2 standard deviations, make a line there, 2 standard deviations to the left, make a line there. And now this area that we shade in here, what does the empirical rule tell us about the area in there? Well, it says that this will be 95% of the data. So 95% of the data will be between this point and this point. And this point is mu plus 2 sigma. Let me try that again. Let me get my eraser tool here. My pen is messing up a little bit. No problem. So this would be mu plus 2 sigma and mu minus 2 sigma. Okay. Now let's look at one more sketch involving this bell shape. Now this time I'm going to go 3 standard deviations to the right and 3 standard deviations to the left. So now we have trapped just about all of the data under this curve. And so according to the empirical rule, that's 99.7% of the data. And so this point here is mu plus 3 sigma, and this point right here is mu minus 3 sigma. So what we can summarize in the empirical rule, these three percentages, we can say it verbally like this. 68% of the data lies between mu minus sigma and mu plus sigma. Now I should add here that these percentages, they are all approximations. So I probably, for accuracy, I should say that approximately 68%. But that 68% is a good rule of thumb. It's a useful percentage to remember. Now another way to say it is 68% of the data lies within plus or minus 1 sigma of mu, plus or minus 1 standard deviation of the mean. Another way is 68% of the data lies within the interval mu plus or minus sigma. Now when it says interval of plus or minus sigma, what I'm thinking about here is a line where I have a point here that is mu minus sigma, and I have another point over here that's mu plus sigma, and that has formed an interval, and 68% of my data would be found between those 2 points. Now for 95%, we can make similar statements. It just goes to 2 sigmas, 2 standard deviations above the mean and below the mean. So again, we can say plus or minus 2 sigma of mu. We can say 95% of the data lies within the interval mu plus or minus 2 sigma. And then for 99.7, same sorts of statements, but we go to 3 standard deviations from the mean. So you need to get used to this notation of plus or minus here. That just means you're going to take mu and add sigma, and then you're going to take mu and subtract sigma. And that's going to give you the interval that contains a certain percent of the data. Now, let's explore this a little bit further. Now that you know the 3 percentages of the empirical rule, let me ask you a few questions. First question is, if I was to shade just this part of my bell curve, can you tell me what percent of the data falls between mu and mu plus sigma? That shouldn't be too hard if you think about it, because we know that from mu minus sigma to mu plus sigma, that's 68%. And I've shaded just half of that 68%. So the answer is 34%. Okay? Now, the next question I want to ask is, what therefore is this area? Shade all this here. That area shaded in green. What percent would that be? Well, if you think about it, the red area and the green area is half of the graph. Half of the graph is 50%. And we know the red is 34%. So if we take 50% and we subtract the 34%, we get 16%. So now we know that this green area in here is 16%. One more simple question is, suppose I decide to shade. I decide to shade starting from here. Shade all this. Shade all this. Okay. So now, what percent have I shaded now? Well, I've got the left half of the graph, that's 50%, and then this section right in here, we already said that was 34%. And so this over here is 50%, the half. So the answer is 84%. We've shaded 84%. And that makes sense because we already knew that this part here, if we had shaded that in green again, we already figured out in the previous slide that this was 16%. So it makes sense for the blue part to be 84%. Of course, these percentages have to add up to 100%. Now let's do a little quick check question. Suppose you have a data set and you're told that the mean is 60 and the standard deviation is 4. Then approximately what percent of the data values are between 56 and 64? Well, you'll notice that if you write 60 plus or minus 4, then that's the same thing as 56 and 64. So this is mu plus or minus sigma. And we know that by empirical rule, that would be 68%. How about from 52 to 68? Well, that would be 60 plus or minus 8. And that would be 60 plus or minus 2 times 4. 4, remember, is your standard deviation. So this is 60 plus or minus 2 standard deviations, where the empirical rule says that 95% of the data, approximately, would be between 52 and 68. And then finally, 48 and 72, that's the same thing as 60 plus or minus 3 times 4. So that's plus or minus 3 sigma. So that's going to be our 99.7%. All right, so this video was just a brief introduction to the empirical rule. If this is the first time you've been seeing this, I would urge you to watch the video at least one more time, let it sink in. The empirical rule is very important, and you're going to see it again in Chapter 5, and you're going to learn a lot more about using the empirical rule and using your calculator to work with bell-shaped distributions. So thanks again. Have a good day.